Hi, this is Beth Olson. I'm a researcher at the University of Maryland's Earth System Science Interdisciplinary Center. I'd like to introduce to you a tool for communities to use in developing a flood resiliency plan. It's called the Community Guide to Assessing Non-Tidal Flood Impacts in Maryland. Funding for the guide came from the Chesapeake Bay Implementation Grant Program. This funding comes from the Environmental Protection Agency through the Maryland Department of Natural Resources. So why do we need a guide for developing flood resiliency plans at the community level in the non-tidal regions of Maryland? Well, to date, most of the tools available to communities have been designed for the coastal and bay communities, where flood risk due to climate change is dominated by sea level rise. Whereas in the Maryland non-tidal regions, they're also experiencing increases in flood risk, but their flood risk is dominated by extreme precipitation events. Extreme precipitation events come in the form of flooding and erosion due to heavy rainfall and spring snowmelt, as well as decreased effectiveness of soil absorption due to extended periods of drought. In assessing flood risk in Maryland's non-tidal regions, it's not one size fits all for all communities in this region. Each of them, or each locality, has what I call microclimates. That is, that there are differences in rainfall and ground surfaces that are very localized. So each community needs to take their individual circumstance into consideration when developing a resiliency plan. So in terms of rainfall, or precipitation in general, there have been increases in most communities. They will have seen increases in intensity, duration, and frequency of rainfall. And then once that rainfall hits the ground, there are various surface components that determine how the stormwater will behave on the ground. And these consist of hydrological components. These are the natural and nature-based components on the ground surface, such as topography and soil types. And also there are hydraulic components. These are the engineered water systems, as well as other man-made structures that influence stormwater behavior. So the Community Guide to Assessing Non-Tidal Flood Impacts in Maryland is designed to help communities develop a community-specific flood resiliency plan. Step one is to initiate a successful flood resiliency project by setting community-specific goals for your resiliency plan, developing the project scope, and taking a system-wide approach to the plan development. Your watershed is going to be your system. So think of a watershed as, well, locate the highest elevation and then follow that down to the lowest elevation, and all terrain within that area from highest to lowest elevation will be your watershed. And choose a watershed that is the appropriate size for your community. Once you have these concepts in place, then there are key actions you can take to successfully finish developing your plan. And these are outlined in the guide steps 2 through 7. In step 2, assemble the internal project team. First, evaluate your internal capacity. Do you have staff members that have expertise in developing part or all of the resiliency plan? And if so, how much time do they have to dedicate to developing that plan? Then select a flood resiliency plan development project manager. This will be the person through which all information about the development of the plan will filter, and they will have oversight over the plan development. Then select an outreach and engagement specialist. This person is important because in order for your plan to be implemented successfully, you need to engage the entire community from its inception to its fruition at the end in order to have full buy-in by the community. And then finally, form a flood resiliency plan preparation task force. The task force, their job will be to organize all of the available data and other documents that the community has prior to starting the planning process so that everything is readily available. Step 3 is to secure funding. Small municipalities are not likely to have the staff capacity needed to develop a flood resiliency plan entirely in-house, usually because staff members already have a full plate in terms of duties and responsibilities and don't have a way to fit in enough time to develop the plan completely on their own. So most communities take a team approach and work together with a hired consulting engineering firm to develop a plan that supports the goals of the community, locate a source of funding, and write the proposal for funding. Step 4 is to gather and organize community data and documents. This is the job of the task force. These include things such as historical maps, drawings, and descriptive documents, recording historic or institutional knowledge from community staff that have many years of experience with community flood risk management, gather together newspaper articles on local flood events, and get the best data available for property lines and ownership. Step 5 is to hire a consulting engineer firm. Primary criteria to consider include their expertise and competence with previous stormwater management projects, knowledge of regional stormwater issues, including trends and projections for future flood hazards related to climate change, expertise with stormwater modeling technology, including scaling to a resolution appropriate for a local community, and their ability to listen to goals and concerns of the community and adapt the project objectives to meet those. Step 6 is to implement the project. So first, compile all of your data. Get your hydrological components organized. These are your natural and nature-based components on the surface of your terrain that influence stormwater behavior. Organize your hydrological components. These are the engineered systems such as stormwater drains as well as man-made structures that influence stormwater behavior. Get the best floodplain maps that are available to your community and find the best source of precipitation data for you to use in your models. The next step is to work with your engineering firm to select the models that you'll use to simulate your stormwater activity in your community. You'll want to do precipitation modeling. These are sometimes called design storm scenarios. This is where your community decides at what level do you want your resiliency plan to accommodate possible flood risk. So you may want to simulate the average flood risk occurring presently in your community. Or you may want to look at the worst case scenario for flood risk. Another option is for the community to think ahead to the future and develop a resiliency plan that accommodates the anticipated increases in flooding 10 years, 20, maybe 50 years out. If you have enough data, you can do a storm drain infrastructure vulnerability assessment. And you'll need a non-tidal riverine systems model. This is a dynamic precipitation and stormwater behavior simulation or series of simulations. And this will show you where the greatest flood risk is in your community. Finally, you will model the socioeconomically vulnerable flood hotspots. You'll do this by locating your socioeconomically important locations in your community. And as a GIS layer, you will overlay that on the riverine systems model map of your highest flood risk areas. So you've got where flood risk and your most vulnerable socioeconomic locations are, and they overlap. That's where your flood hotspots are located. And then finally, you will select appropriate stormwater best management practices for the community and apply those to your flood hotspots. Now, the best practices may differ from one location to another depending on the characteristics of flooding in that location. Step 7 is to integrate the project results by disseminating the plan throughout the community and also to stakeholders and other interested parties outside of the community. And have a clear community-wide plan for financing stormwater management systems, both green and gray components. Green components are the natural and nature-based features, and gray components are the engineered features, such as stormwater piping systems. In conclusion, don't wait. The challenges are many, but they are not unsurmountable. So get started on designing your flood resiliency plan for yourselves and for your future generations. I'd like to thank Megan Granado of the Maryland Department of Natural Resources for her collaboration on developing this guide. I'd also like to thank the engineering and design firms, as well as the Department of Public Works in the cities that participated in our case studies. And I'd like to thank the project's pilot community that also participated in developing this guide. The full guide is available on the Department of Natural Resources website. And if you would like more information, please feel free to contact me, Beth Olson. And good luck with developing your community's flood resiliency plan.